হ্যালো স্যার, একটা কোয়েশ্চেন ছিল স্যার।
Discuss about the Runge kata methods for solving the ordinary differential equations. And in this method, at first we will discuss how to solve the first order ordinary differential equation. That means in the form of dy by dx is equal to f of x y as a function of x and y. So already we solved these same problems by using two another methods. First one was the Picard's methods, and thereafter the Euler's methods, having different variants, modified Euler's method and improved Euler's method as well. And at this lecture, today's lecture, we will first discuss the Runge kata methods, different orders, starting from first order to fourth order, and thereafter we will go for simultaneous first order differential equation, how to solve the simultaneous first order differential equation. That means something like this, dy by dx, and then there may have another function dz by dx, like this. If you have a 3D coordinate system, that means x y z, and if the curve or equation lies in a space, so in that case you need to represent the total things with the two equation. And sometimes for second order ordinary differential equation like this, d square y by dx square plus dy by dx multiplied by some function of xy is equal to f of xy. Like this is the generalized form of second order differential equation. So we can also solve such types of problems by using this method. So let's start with the basic principles of these methods. So, as we discussed earlier at the very beginning of solving ordinary differential equation, one conventional method is the Taylor series. So, we start from actually that points in Picard's method. We simply ignore the higher orders of Taylor series. So, it may sometimes give you less accuracy. That's why here we are today we will discuss Runge kata method. We only discuss the equations, that means how to find the y values for corresponding successive approximations, and we only discuss the equations and how to calculate the values, and thereafter we will go for a numerical example. And last night I sent you an Google Classroom, I sent an assignment regarding numerical interpolations as I discussed in last class. So hopefully all of you are doing working with that assignments, and the deadline is Sunday. So on Sunday we have also scheduled for class test or short quiz. So and the syllabus will be numerical interpolation, numerical integration, numerical differentiation, and actually up to last class. So I think you need to only read the basic principles for each method. So there will be something like multiple choice or fill in the blanks types questions, so you not need to go for the preparation with the details mathematical problems. Just the basic principles and the working principles of each method, that's enough. So hopefully you will prepare yourself within this weekend.
স্যার, একটা কোয়েশ্চেন স্যার।
So let's start the first order. Actually, the first
স্যার,
order
শোনা
Runge
যায়?
kata method, that is nothing but the same process of same equations of Euler's method. So I am ignoring that one. The first order. The first order Runge kata method, that is actually identical with Euler's method. Euler's. That means the equation is as before, y1 is equal to y x0 plus h, function of x0 plus h. So this is as before. Let's start. We will discuss from the second order. In second order Runge-Kutta method, here the algorithm for calculating the y values using the second order Runge-Kutta method, the algorithm is following. So I am not showing the details of the Taylor's theorem for these derivations. I am simply showing you the how to calculate the y values. In this case, y1 will be y0 plus k, a constant value k. So the now question may arise, we can calculate this k value. The k for the second order Runge-Kutta method, k is equal to half of k1 plus k2. So again two unknown constant k1 and k2. So you can find k1 by this k1 is equal to h function of x0 y0, and k2 will be h function of x0 plus h y0 plus k1. Okay. So at each and every steps you should start from k1 is equal to h of x0 y0 and k2. Then thereafter you will find the k, and y1 is equal to y0 plus k. So again when you go for second trial, that means this is your first trial y1, and when using the second order Runge-Kutta methods, you may need to go for successive approximations based on your the problem statements. That means at last class we solved the problems where we need to go for y1 y2 and y3 to reach the limit of the ordinary differential equations. And at this case also, if I go for the second trial, that means y2 will be simply y1 plus k. At this stage the k value will be changed. In successive stages k value will be changed. K is as before half of k1 plus k2. So k1 will be, for this case k1 will be function of x1 y1. Okay, y1 is known, y1 is x1 is known, x1 is nothing but x1 is equal to x0 plus h, and y1 is also you have already found from the first step. So this is known, and k2 will be h f of x1 plus h, and at this case y0 this will be replaced, this will be y1 plus k1. Okay, and this k1 is actually for second step. Okay, at second step you find another k1 and you will use this k1 to calculate the k2 of the second approximation. So these are the algorithm for second order Runge-Kutta methods, and now we will go for the third order and fourth order, that means higher orders. For higher orders the procedure is same, simply there will be variation in the calculating k values. So I first of all I would like to show the equations for higher orders. So at higher orders, Runge-Kutta method of third order. Let's start this one. Third order. At all types of ordinary differential equation problems, of solving such types of problems, you simply need to memorize the algorithms, that means the equations for the third order Runge-Kutta method. Actually your y1 will be y0 plus k as before. So at this stage k is equal to 1 by 6 of k1 plus 4 q4 plus k3. Okay, so now I need to calculate the k1 to k4. Here k1 is equal to h f of x0 y0 as before. K2, this is equal to h function of x0 plus h, that means x1, and y0 plus k1. K3, K3 will be h multiplied by function of x0 plus h, y0 plus k2. So you need to follow the steps sequentially. That means at first you should start from k1. You can calculate the k1, then you will go for k2. Okay, and when you come to k2, you need the value of k1. That means this value will be used in calculating k2. Again, when you go for the k3, you need the value of k2, and this will be come from the previous step. Then you will come for finally k4. K4 is nothing but h function of x0 plus h by 2, y0 plus k1 by 2. Okay, this k1 is nothing but from first step. Okay, so this is your first trial. That means while you are calculating for y1, again if you go for y2, y2 will be simply y1 plus k, and again this k is equal to 1 by 6 k1 plus 4 k4 plus k3. Again k1, at this case k1 will be h function of x1 y1. So x1 is nothing but x0 plus h, and y1 is already you got already y1 from the first trial. So at this all cases you will use the your approximated value of y1 for the first step. So this is k1, and then go for k2 k3 up to k4, following the same process. So this is the Range-Kutta method of third order, and for the fourth order, the equations will change. Now, if I show the fourth order, so one thing you only need to memorize. So for the first order, okay, the third order Range-Kutta methods, these are the algorithms, these are the equations. Again, for the fourth order, these are equations. So you need to memorize for which methods, the algorithms and the details. For the fourth order, here k1 will be as before h f of x0. One thing you can see that the k1 value is almost same. The algorithm of k1 is same for all cases. So, and for k2, this is h function of x0 plus h2 h by 2 y0 plus k1 by 2. K3, this will be h function of x0 plus h by 2 y0 plus k2 by 2. And k4, the k4 value will be h multiplied by function of x0 plus h and y0 plus k3. So finally you will get the k1 to k3 k4, then calculate the k value 1 by 6 of k1 plus 2 k2 plus 2 k3 plus k4, and y1 is equal to y0 plus k. Very simple. x1 is equal to x0 plus h. Okay, so these are the known. So for each cases only the k value is changing. That means the k for fourth order k value will depends on k1 k2 k3 and k4, and corresponding k1 k2 k3 k4, these equations are also changing based on this method. That means the third order or fourth order, anyone. So let's start with an numerical example. With an example, here you have given y prime is equal to x square minus y0 is equal to 1. So you are asked to find y 0.1 and y 0.2. These are what? Okay, using the Range-Kutta method of second order, third order, and fourth order. Using of first, second order, then third order, and finally fourth order. So let's do it. The starts with the first order. Before starting the second order, sorry, before starting the solution, we need to do some preliminary steps like this. Y prime is equal to x square minus y. So this is nothing but y prime. Y prime means actually dy by dx. Slope dy by dx is equal to x square minus y. So for this problem, the function of xy, that means f of xy is equal to this one, x square minus y. So you get the your desired function. Now another one, we need to the value of x0 and y0. The as it is an ordinary differential equation of first order, so I need at least one boundary conditions. That's called the initial value problem. So for these problems, the condition is given already in the equations. That means y0 is equal to 1. That means at x is equal to x0, that means x is equal to 0, y is equal to 1. Okay. So at x is equal to x0 is equal to 0 and y0 is equal to corresponding y value is 1. So another thing we need to approximate, that is the h value, equal interval. So look at these questions. Here it's you are asked to find the value of y0, y0.1 and y0.2. So if I take h is equal to 0.1, okay, if I take the h is equal to 0.1 after the first trial, that means my y1 will be nothing but y 0.1, and second trial, that means y2 will be y of 0.2. Okay, so I need to go for two successive approximations, or anyone can think, okay, I will go for further accuracy, so I can go for x is equal to 0.05. Maybe you must choose 0.05. So if you choose the 0.05 for reaching y value 0.1, you need the two step. Okay, first one will be 0, y1 will be 0.05 and then 0.1, and to go for y2 respective to y value respective to 0.2, and you need to go for 4 step. That means 0.05, 0.1, 1.15 and then 0.2. Okay, the number of trials and approximation, this is actually depends on your h value. That means how many steps you are counting based on this. So let's start second order. Okay, another things. So I get the x0 and y0. So if I want to calculate the f of x0 y0, so x0, that means this is 0 is square minus this is 1. So f of x0 y0 is simply minus 1. Okay, so for second order, the second order Runge Kutta method, we know the y1 is equal to y0 plus k. So here k is equal to half of k1 plus k2, we know. Then go for k1 is equal to h f of x0 y0. We already calculate the f of x0 y0, that is nothing but minus 1, and h value we assumed that h value will be 0.1. That means 0.1 multiplied by minus 1, this will gives you the minus 0.1. Okay, then k2 will be h function of x0 plus h y0 plus k1. That means h function of x0 plus h, that means our x0 is 0, and if we add it h value, that means 0.1, that means function of 0.1 y0 plus k1, and y0, our y0 value was 1, so 1 plus k1 we got already minus 0.1. That means this will be 0.1 0.9. So at this function, your initial function f of xy, if you put the x value is 0.1 and y value is 0.9 in this equation, this will gives you like this. H value is already we know the 0.1 multiplied by x our function. Okay, let's let me recall here. This is our function f of xy is equal to always x square minus y. So always memorize this function, and at this function we will put x value 0 0.1, that means 0 0.1 square minus y value is 0.9, so it is 0 0.9. So after solving you will get the k2 will be minus 0.089. Okay, so now if you put k1 and k2, after putting this you will get minus 0.0945. This is um, so now I will start for k1. K1 is equal to y1 is equal to y0 plus k. Our y0 value was 1 plus k. K is minus 0.0945. So finally y1 will be 0.9055. Okay, so this is actually y1 is equal to nothing but y 0.1. So your first step is already done, and next one y2. So again if you again taking x1 is equal to, at this step y1 is 0.9055, that means corresponding x1 is equal to x0 plus h, that means 0.1. Okay, so again if it starts from x1 is equal to 0.1 and y1, at this step y1 is equal to 0.9055 in place of x0 y0. So if we at this step we start from here, repeating the same process, and if we repeat the same process. Okay, so I will go for some simplification. I am repeating the same process. I am simply copying the same thing. So if we repeat the same process y2, this will be y1 plus k. Okay, so let's start again. y2 will be y1 plus k. Now the k1 value, for k1 at this stage you will start from x1 y1. Okay, so f of x1 y1, this is nothing but h value 0.1 as before, function of x1 is equal to 0.1 from last step. Look at this, x is equal to 0.1, y1 is 0.9055. So you simply put this value in place of x and y, you will get f of x1 and y1. So after putting this and simplification, that means this will give you k1 value minus 0.08955. Okay, you will simply put here 0.1 square minus 0.9055. Simple. After calculating you will get the k1 value, and for k2, okay, for k2 the k2, this will be h function of x1 plus h and y1 plus k1. So k1 is already calculated just previous step. So you will here k1 multiplied by function of x0 plus h, x0 plus h, x1 plus h, that means at this case this will be 0.2, that means 0.1 plus h, 0.2, and y1 plus k1. The y1 value is 0.9055 and k1 is minus 0.08955. So I can simply put here 0.81595. Okay, this is actually 0.1 multiplied by x square minus y, so 0.2 whole square minus y value means this one, 0.81595. So after solving this problem, you will get minus 0.07759. So you already calculate k2 and k1. So the k value will be finally minus 0.08357. Okay. So if you once get the k value, so now the k2 will be y1 plus k. So here y1 was 0.9055 plus k value is minus 0.08357. So you will get on some value like 0.8219275 like this. So at this case here y 0.2 0.8219257, sorry, 275, and this is for, this value is for x is equal to x1 plus h, that means x is equal to 0.2. So this is your desired second result. Okay, so we have two target. First one is to calculate y1 at y is equal to 0.1 and at y is equal to 0.2. So after first trial we get the value of y1 at x is equal to 0.1 and then for x is equal to 0.2. So this is the numerical example for Runge Kutta methods, and I will hopefully the other two methods, that means two order, say third order Runge Kutta method and fourth order Runge Kutta method for the same problems. I think you may solve this at home. You should try because the procedure is same. Okay, the mathematical procedure is same. At the very first, you need to form your, the very first step, users simply need to formula f of xy. First you need to identify, okay, this is our function. Okay, after identifying the function, at the next step you need to find out your the value x0 and y0. Okay, once you get the x0 and y0, another thing you need to find out or choose. Sometimes in questions it's may clearly state that, okay, use the h value 0.1 or 0.2 or something, or if not given, you may choose a suitable value, any suitable h value. Okay, that's up to you. So choose any reasonable value of h, and then depending on the order, that means if it is second order or third order or fourth order, you need to recall the corresponding set of equation. That means for second order I am using these equations. Okay, and now if I go for the third order methods, I will use the this set of equation, and for if I ask to go for fourth order Runge Kutta methods, then I will use the this set of equation. Okay, only changing things is the set of equation, that means the k1 to k4 and k up to k, and y, these are the actually as usual, that means y1 is equal to y0 plus k, y2 is equal to y1 plus k. Okay, these are the same thing. So you need to only recall the algorithms and the equations. So try to remember these equations. So now if I go for solve you the third order, you will use this equation, that means k1 is, for this step we will simply use this equations. So I think the third order method and the fourth order, these two method you should try at home. Okay, this is your homework. Will try. And this is an workout example for BNS from BNS Murthy, article 11.38. So you may recheck your results with the books. So the same process, the process are same, simply the changes in the calculation process and the equations. So if you solve for both method, I am just finally showing the variations in results. Suppose I am summarizing the variations results y1 and y2. Okay, if you solve by second order and fourth order. So if you solve by second order, we already solved this. We get the y1 value. Y1 is, we got 0.9055 and 0.8219275. Okay, and if you go for third order, using the third order method, you will find 0.90515, and fourth order you will get 0.9051627. So that's all about accuracy. Okay, if you go for the higher order, your accuracy will increase. So this is the technique how to use. And for the second y2 value, corresponding y2 value will also be changed, 0.8212449, and this one this one will be 0.8212695. Okay, so these are the basically changes, and you will find a change in the result, as well as you will find a change in the. Okay, so if I go for some other problems, so at next class hopefully we will discuss the Runge method for second order differential equations. Before that, I will try to show simultaneous first order differential equation. So I think you may familiar with the simultaneous first order differential equation. So let's show the basic form. Order simultaneous first order equations. Okay, so the simultaneous first order differential equations are like this: dy by dx is equal to f1 x y z and dx by dz, this will be f2 x y z. Actually here is two independent differential equation. First one is this is also first order differential equation, and this is also first order differential equation, but for these two equation there is a link up, that means one depends on another. Okay, so for such types of problem, we actually need two initial condition. That means as the number of unknown is 2, at this stage we need two initial condition: y of x0, this will be y0, and z of x0. is equal to z0. That means if I consider x as an independent variable and then two other variables y and z are varying with x, following these two equations dy by dx and dx by dz, that means two form. So in this case you need two initial value, initial boundary conditions, that's are called the boundary value problems. So these simultaneous first order differential equation, this is actually nothing but a boundary value problem. So these conditions you should be known. These two conditions, that means x0, y0, and z0. These two three values are should known. And if you get these three values, so you can simply calculate by using the previous techniques. I am just like to simply like to recall these equations. This is also very similar to first order differential equation with a single variable. The very similar, just let me show. So simply if I show the second order Runge-Kutta method for simultaneous first order equation. Okay, so let's start with second order. Okay, if for second order method we know for second order y1 was y0 plus k. So another part here we will add, and z1 will be z0 plus, at this case we need to consider another constant value, that let's consider it as L. Okay, y1 will be y0 plus k and z1 will be z0 plus L. Okay, let me show side by side. So at second order, if I already solved, k1 was h f of, at previous it was f of x0 and y0, but at this case we have three variables, so this is actually function of x, y, z. That means f1 of x0, y0, and z0. Similarly, L1 will be h f2 of x0, y0, and z0. Okay, then k2, this will be h f1 of x0 plus h, and previously it was x0 plus h, y0 plus k1. Okay, but at this stage we have the function of f1 is depends on three variable, that means x, y, and z. So here you will have another additional term, that will be x0 plus h, y0 plus k1, and another term that will be z0 plus L1. Okay, so this L1 value, you will get this L1 value directly from this. That means while you are solving a problem, you need to go for side by side solution. That means, and simultaneous solving, and then you will go for you will come for L2. The L2, this will be h function of f2 of x0 plus h, y0 plus k1, and z0 plus L1. So this L1 value is already calculated, so you will simply find this, and finally k is equal to half of k1 plus k2, and L is equal to half of L1 plus L2. Okay, so here I am showing the very simple one, that is the second order Runge-Kutta method. And if you go for the higher orders, that means for third order and fourth order, the equation will be similar. Okay, like this. So suppose for fourth order, the equation will be similar, but if you are going to solve for y, in that case, you will need to consider the f1 of x, y0 and x0, y0 and z0. Similarly, additional part will be added here. That means x, y, z. This is function of x, y, z. And while you are using for the k1 corresponding L1. Okay. Suppose for fourth order, if you solve for the simultaneous equations, in that case your k2 value, this will be relation f1 of x0 plus h by 2, y0 plus k1 by 2, and z0 plus l1 by 2. So if you go for simply first y1 and then for z1, that will be difficult. So you need to go for side by side. That means corresponding calculation. First you will calculate k1 L1, then K2, L2. Finally, the K value and L value, and then finally Z and Y. Okay. So I think at next class we will solve a problem regarding to simultaneous first order differential equation, and then we will see for second order differential equation. Okay. So now if you have any questions related to today's lecture or assignment, you may ask. ওকে, একজন লিখছে কোশ্চেন রিগার্ডিং অ্যাসাইনমেন্ট। আচ্ছা, অ্যাসাইনমেন্ট ব্যাপারে কি কোশ্চেন বলো দেখি।
স্যার শোনা যায়?
অ্যাসাইনমেন্ট রিলেটেড কোনো কোশ্চেন থাকলে জিজ্ঞেস করতে পারো, অথবা তোমরা ক্লাসরুমে কমেন্টস করলে আমি সেটা দেখিয়ে দিব।
স্যার আপনি কি
ক্লাসের ব্যাপারে কোনো কোশ্চেন থাকলে সেটাও করতে পারো।
সাজিদ স্যার মনে শুনতে পাচ্ছেন?
কেউ মনে হয় প্রেজেন্ট আছে কি? আচ্ছা হ্যাঁ, সরি, আচ্ছা মিউট করা ছিল, শুনতে পাচ্ছিলাম না। হ্যাঁ বলো।
স্যার অ্যাসাইনমেন্টের যে 4 নাম্বার কোশ্চেনটা আছে ওটা স্যার একটু কিভাবে করব স্যার বুঝতেছি না স্যার।
4 নাম্বার কোশ্চেন, 4 নাম্বার কোশ্চেনটা ছিল, দাঁড়াও আমি একটু দেখি।
স্যার এটা তুমি ইন্টারপোলেশনের না?
না, ওটা ইন্টারপোলেশন না, আমি তো কালকেই বলছিলাম ওইটা তোমাদের নিউমেরিক্যাল কি ছিল, এটা হচ্ছে নিউমেরিক্যাল ডিফারেন্সিয়েশন। ওকে, ডিফারেন্সিয়েশন থেকেই ইন্টারপোলেশন একটু এক্সটেন্ডেড পার্ট। ডিফারেন্সিয়েশন যেহেতু ওপেন অ্যাসাইনমেন্ট, তো তোমরা হচ্ছে এটা একটু করে দেখে নিবা, ঠিক আছে? তোমরা এটা ছিল কোথা? Suppose a non-stop intercity train was traveled from Chittagong to Dhaka starting at 7 a.m. Okay, the travel distance from the origin station are recorded at 1 hour interval, okay, and listed below. So find the speed and acceleration of the train at 12:30. Okay, so here the given data is distance, time versus distance, and you are asked to solve for speed and acceleration at a certain time. So I think I discussed these types of problems in class, the techniques. First you need to consider the problem, and then you need to set the policy. Okay, if I go for speed, what should I do? And if you go for asking for acceleration, what should you do? And then you should another technique, that is the time is 12:30. Okay, and this zero distance, this is actually at 7. Okay, that means 7, 8, 9, 10, 11, 12 and 1 p.m. Okay, these are the given data, and then you need to rearrange your data in a corresponding x, y values and so on after solving. successive steps, you will get the desired speed and acceleration. Okay, so should try. আচ্ছা, তাহলে এইগুলো অ্যাসাইনমেন্ট পেপারে। আর রোববারে তোমাদের যে কুইজটা হবে, শর্ট কুইজ, সো ওইটা তো সেম লাস্ট ক্লাস পর্যন্ত, আমি আজকের ক্লাসটা ইনক্লুড করতেছি না, লাস্ট ক্লাস পর্যন্ত যতগুলো মেথড পড়ানো হয়েছে স্টার্টিং ফ্রম নিউমেরিক্যাল ইন্টারপোলেশন, প্রত্যেকটা মেথড কি কাজে লাগে এবং কখন সুইটেবল, কেন কোন মেথড সুইটেবল, কোনটার ক্ষেত্রে সুইটেবল না, এই জিনিসগুলো একটু খালি জেনে নিবা, কেন সুইটেবল, লজিক কি, এই বেসিক গুলা। মেথড তো কিছুই না, নিউমেরিক্যালি সিম্পলি তোমার ইকুয়েশন গুলো মুখস্থ করতে হচ্ছে, সেই ইকুয়েশনে তুমি ভ্যালু বসাবা, চলে আসবে রেজাল্ট। এবার সাকসেসিভ ইটারেশন করতে হবে 2 বার 3 বার 4 বার, যে কয়বার, বাট তোমার হচ্ছে কেন করতে হচ্ছে সেটা একটু, বা কেন কোন মেথডটা চুজ করতেছো, এই জিনিসগুলো একটু জানবা। এগুলোর উপরেই থাকবে মোটামুটি কুইজটা। সো টাইমটা হবে সানডেতে তোমাদের 1টা থেকে ক্লাস, তাই তো?
স্যার আমরা 11টার দিকে স্যার ফ্রি আছি।
11টা থেকে ফ্রি, ঠিক আছে, তাহলে 11টা থেকে। এবং ইয়েটা করবা যেটা তোমরা, স্টার্টটা হবে ক্লাস টেস্ট দিয়েই, দ্যাট মিন্স আমি প্রথমে ক্লাস টেস্টটা নিয়ে দেন হচ্ছে ক্লাসরুমে হবে গুগল ফর্ম সিস্টেমে, সঞ্জয় স্যার যেভাবে নিচ্ছে ওইভাবেই আমি দিয়ে দিব। দেওয়ার পরে দেন ক্লাসের, আর আমাদের এই অল্প একটু বাকি আছে, সেকেন্ড অর্ডার ডিফারেনশিয়াল ইকুয়েশন, একটা ম্যাথ দেখায় ওইটা সলভ করে দিব। ওটা সলভ করে দিলে মোটামুটি আমার সাথে কোর্স সিলেবাস মোটামুটি শেষ হয়ে যাবে। সো হোপফুলি আর বাকিটা নিজেরা একটু দেখে নিবা, ঠিক আছে? মোটামুটি আমি সবগুলো টপিকই কভার করলাম লাস্ট ক্লাসে, আগামী ক্লাসে হয়তো শেষ হয়ে যাবে, এই তো। তো আর কোনো কোশ্চেন আছে আজকের ক্লাসের ব্যাপারে? না থাকলে আমরা ক্লাসটা ক্লোজ করি মনে হয়। আর তোমাদের ক্ষেত্রে যেটা আমি লাস্ট মনে হয় কয়েকটা উইকে খেয়াল করতেছি, পার্টিসিপেশন অত একটা ভালো না, 90, 92, 95। এখন সবাইকে একটু ইনফর্ম করে দিবা ক্লাস টেস্টের ব্যাপারে, ওকে? যদি অ্যাবসেন্ট থাকে সো সেক্ষেত্রে তো আর কিছু করার নেই, তো এটা রিয়েল টাইম, এখানে আসলে এমসিকিউ টাইপ কোশ্চেন, সো এটা একটু কুইক করে ফেলতে হবে এবং সবাইকে টাইমলি প্রেজেন্ট থাকতে হবে। সো এটা গেল একটা। আর অ্যাসাইনমেন্টও টাইম দেওয়া আছে, দেখবা ওই টাইমের মধ্যে করে জমা দিয়ে দিবা, আশা করি হয়ে যাবে, যাতে লেট যাতে না হয়। হ্যাঁ বলো।
স্যার কুইজটা তো স্যার আজকের ক্লাসটা বাদ দিয়ে,
হ্যাঁ লাস্ট ক্লাস পর্যন্ত, ইউলার্স মেথড পর্যন্ত তোমার যতগুলো মেথড পড়াইলাম এই মেথডগুলোর উপরেই কোশ্চেন থাকবে, ওকে? সো ঠিক আছে, আজকেরটা ক্লোজ করলাম, ওকে?
আসসালামু আলাইকুম স্যার।
তাহলে সানডে 11টা, ঠিক আছে?
জি স্যার।
আচ্ছা, আমি গুগল ক্লাসরুমে লিখে দিব কুইজের ক্লাস টেস্টের টাইমটাও, ঠিক আছে? ওকে।